Okay, today I'm introducing Hooke's law for springs in physics, and I want to make this as easy as possible. So imagine you have this sequence of numbers, 1, 2, 3, 4, all the way down the list. And to each one of those I pair off. Let's say this goes to 75, and then this is 150, and then this is 225. And then I asked you what the next number was. Well, after you spent some time with it, you would realize that these are going up by 75, right? So basically, the next number in the list would end up being 300, okay? And this relationship you probably know is a linear one, all right? Every increment, you go up 75. Okay, now, what this means for springs now, if I have a spring and I tell you the spring constant is 75, and notice the unit is newtons per meter, which we'll talk about in a minute, what that means is if I grab hold of that the spring, and I pull it to the right, if I pull it 1 meter, okay, that means the spring is going to have a resistive force of 75 newtons. If I keep on stretching it and I pull it back to 2 meters, well, that means now, okay, it's going to have a resistive force of 150 newtons, which matches that. And basically, for every meter I pull it, it's going to resist me with 75 more newtons. That's exactly what the spring constant means. Now, the same kind of thing is going to work if I take that spring and I compress it instead of stretching it. So here's my x equals 0 mark, right? That's x equals 0. And now imagine I take the spring and I squish it that way. Now, if I squish the spring in such a way, right, that I compress it to here, and then that would make this -1 if I pushed it in a meter. Well, that would mean that the spring would push to the right with a force of 75. And then if I squished it in 2 meters, it would push to the right with a force of double that, 150. It would keep going up by 75 newtons for every meter I pushed it. So basically what that leaves us with is the force that a spring exerts is equal to K times delta X, where delta X is the distance, the displacement from equilibrium that you are on the spring. But we typically put a negative in front. And all the negative means is, think about it. If I pushed it to the left, the spring is going to push to the right. And up here, if I pulled it to the right, the spring is going to pull back to the left. So it's always opposite whichever way the force is applied to the spring. Okay, let's do a couple of quick problems right now. First, on this problem, we have a spring that's pulled to the right and held in equilibrium by F, and we want to find X, the distance the spring is pulled, and we know the constant is 140. So, first off, if the holding force is 28, that means the spring is pulling back with a force of -28. So knowing this, there's the formula for the force that a spring exerts. X is equal to 20 centimeters.